Hi, in this video I will share the IGNOU University MCA Software Engineering Subject Solved question paper of the term end examination December 2022. All question with perfect answers. The question paper screenshot as follow as. What are the different methods used for estimating the cost and efforts required for completing a project successfully? Explain any one of the methods. There are many different types of project estimation techniques used in project management with various streams. A project manager is often challenged to align mainly 6 project constraints: scope, time, cost, quality, resources, and risk in order to accurately estimate the project. Firstly, what are project estimation techniques? Project estimation techniques refer to the procedures and tools used to develop rough calculations of various aspects of any project. An excellent example of this is a project cost estimate that provides an overview of the anticipated expenses associated with the project. The diagrammatic view of project estimation techniques as follows. The first one is top-down estimate. In the top-down estimating method, you determine the total cost of a project and separate the cost into smaller categories. The next one is the bottom-up estimate. This technique is used when the requirements are known at a discrete level where the smaller work pieces are then aggregated to estimate the entire project. The next one is analogous estimating. This project estimation technique is used when there is a reference to a similar project executed and it is easy to correlate with other projects. Expert judgment and historical information on similar activities in a referenced project are gathered to arrive at an estimate of the project. The next one is the parametric estimate. This technique uses independent measurable variables from the project work. The parametric estimating method involves using historical data to determine the costs of each part of the endeavor. The next one is the three-point estimating. This technique uses a mathematical approach as the weighted average of an optimistic, most likely and pessimistic estimate of the work package. The next one is the what-if analysis. This project estimation technique uses assumptions based on varying factors like scope, time, cost, resources, etc., to evaluate the possible outcomes of the project by doing impact analysis. These are the basic project estimation techniques with small descriptions. Then we can go through the detailed view of one commonly used method is the analogous estimation. Analogous estimation, also known as top-down estimation or expert judgment, relies on historical data from similar projects to estimate the cost and efforts of the current project. This method assumes that the current project is similar to past projects in terms of scope, size, and complexity. The basic idea is to use the actual costs or efforts of past projects as a basis for estimating the efforts of the current project. Here's a step-by-step explanation of the analogous estimation method. The first one is collect historical data, gather data from past projects that are similar in nature to the current project. This data should include information on the project's scope, size, duration, and costs. The next one is identify key parameters. Identify key parameters that influence the project, such as size, complexity, and resources required. These parameters should be comparable between the past projects and the current project. The next one is calculate ratios. Calculate ratios of the key parameters from the historical projects. For example, if the past project was twice the size of the current project and cost $100,000, the size-to-cost ratio would be 2:1. The next one is apply ratios to current project. Apply the calculated ratios to the corresponding parameters of the current project. The next one is adjust for differences. Consider any significant differences between the past projects and the current project and make adjustments accordingly. Factors such as technological advancements, changes in team composition, or unique project requirements may necessitate adjustments to the initial estimation. We can conclude that analogous estimation is a quick and relatively simple method, but its accuracy depends on the similarity between the current project and past projects. However, It is essential to exercise caution and consider the unique aspects of the current project to ensure accurate estimates. The next question is explain McCall's quality factors. McCall's software quality model was introduced in 1977. It's proposed by John McCall, is a model that identifies 11 software quality factors. These factors are crucial in assessing and measuring the overall quality of a software product. McCall's model provides a comprehensive framework for evaluating different aspects of software quality. The 11 quality factors are divided into 3 categories: product revision, product transition, and product operation. The first one is correctness. A software system is expected to meet the explicitly specified functional requirements and the implicitly expected non-functional requirements. If a software system satisfies all the functional requirements, the system is said to be correct. The next one is reliability. Customers may still consider an incorrect system to be reliable if the failure rate is very small and it does not adversely affect their mission objectives. Reliability is a customer perception, and incorrect software can still be considered to be reliable. The next is efficiency. The efficiency concerns to what extent a software system utilizes resources, such as computing power, memory, disk space, communication bandwidth, and energy. A software system must utilize as little resources as possible to perform its functionalities. The next one is integrity. A system's integrity refers to the extent to which access to software or data by unauthorized persons or programs can be controlled. Integrity is crucial for maintaining the confidentiality and accuracy of data. The next one is usability. Software is considered to be usable if human users find it easy to use. Without a good user interface, a software system may fizzle out even if it possesses many desired qualities. The next one is maintainability. Maintenance refers to how easily and inexpensively the maintenance tasks can be performed. Maintainable software allows for efficient updates, bug fixes, and adaptation to changing requirements. The next one is testability. Testability means the ability to verify requirements. The ease with which the software can be tested to ensure its correctness and reliability. Testable software simplifies the identification and resolution of defects. The next one is flexibility. Flexibility is reflected in the cost of modifying an operational system. In order to measure the flexibility of a system, one has to find an answer to the question, how easily can one add a new feature to a system? The next one is portability. Portability of a software system refers to how easily it can be adapted to run in a different execution environment. Portability gives customers an option to easily move from one execution environment to another to best utilize emerging technologies in furthering their business. The next one is reusability. Reusability means if a significant portion of one product can be reused, maybe with minor modifications, in another product. Reusability saves the cost and time to develop and test the component being reused. The next one is interoperability. Interoperability means whether or not the output of one system is acceptable as input to another system. It is likely that the two systems run on different computers interconnected by a network. Interoperable software facilitates seamless communication and integration with other systems. McCall's quality factors provide a systematic way to evaluate and prioritize different aspects of software quality, helping developers, testers, and stakeholders assess and improve the overall quality of a software product throughout its life cycle.